So, we already explained the definition of software engineering. Next topic we have to study is whether the software engineering is an engineering discipline or not. So, when you ask some experts, one set of experts will say that it is not a true engineering discipline because if we are not using any fundamental theorems, laws of physics, like that. But some of them will say that the software engineering is an art because artistic talent is needed, the creativity is needed in order to create the software. But nowadays, software engineering is trying to become an engineering discipline, a true engineering discipline, with the help of rigorous approaches, different standards, uh, like that, and a lot of paper education, or a lot of education is given through this to this particular area, that is different certification courses, different training which is given to the software engineering discipline, and that is why we can say that now it is more and more becoming an engineering field. So next is we have to study the main difference between two types of engineering, that is called the software engineering and system engineering. What is the difference between these two engineering? That is the first point we have to study. You know the meaning of a software engineering. In the case of software engineering, we will create a software as your product, final product, and we have to pass through different steps in order to create the final product. But in the case of system engineering, here also we are creating a product, and the product may be any hardware or anything like that. For example, we can consider a car, we can consider a bulb, we can consider any kind of such system that is which is manufactured is called a system engineering. So system engineering means we are manufacturing. It is a base term, it is a common term which is used in order to manufacture any particular product. So we can say that in both the engineering, that is in the case of system engineering and in the software engineering, actually we are getting a product, but based on the product we are categorizing them into two categories. In the case of software engineering, the product will be a software, and in the case of system engineering, it can be any particular system, that is a manufacturable system. And whatever may be the product we are going to explain, we have to pass through different steps. And here I will give you a comparison, that is just the name given to each steps. In system engineering and software engineering, we are using two different terms, but the meaning description is given as the third column, which will give you what you are doing in each of these steps. So the first step we have to consider is, in the case of system engineering, the first step is problem definition, and in software engineering we will use the term requirement analysis. And this is usually the first step. So what is the meaning of these steps? The meaning is that if you want to create a product, the first thing is that you have to identify the problem, or you have to capture the requirements of the customer, and that is done in this problem definition. Okay, and the customers will explain, that is who wants that particular product, that is who need that particular product. They will explain their needs, they will explain their constraints, like that. Okay, so which is very important in order to create the product. Needs means what they want. For example, if you are considering a software system, they will say that they want a user friendly system. Okay, and in the case of constraint, they will say that I have only this much of money with me, you have to create a software within 1 lakh amount, and in the case of time constraint, we can say that I need to create the software within 6 months. So these are some examples of constraints. Okay, so like that, if it is a system engineer, if you are going to create a product, or if you are going to create a software, the first phase, which is problem definition or requirement analysis, which means that here the creator will try to determine the needs and the constraints of the customers. They will analyze the requirements, and according to that they will make the software. The second phase is the solution analysis. In the case of system engineering, which is called solution analysis, in the case of software engineering, it is called software design. So after collecting the needs or the requirements or the problem definition, the next step is different methods will be there in order to solve the problem. Different alternative methods will be there which satisfy those constraints. Okay, and the choice, that is it is the task of the analyzer in order to choose the optimized solution. Okay, so that is done in the second phase, solution analysis or software design. Means different methods will be there, or different ways will be there, different solutions will be there in order to solve the problem which is explained in the first phase. Okay, but the selection of the best one is done in this, that satisfy the needs and constraints will be done in the second step. Next comes the third field, which is common name used in both the engineering, that is called the process planning. If you want to create a product, whether it is a software or whether it is any hardware, whatever may be, whenever we are going to create a product, the creation is actually divided. The entire creation task is divided into different subtasks. And we have to decide the precedence, in which order these tasks should be done in order to create the final product. And there may be certain risk to the project. Risk means potential risk will be there. Suppose that if the first task delays for some more time, suppose its allotted time is 1 week, and suppose it is extended to 2 weeks or 3 weeks, eventually it will affect the creation of or the completion of other tasks also. Okay, so if any risk is there, we have to consider the risk in advance. So that is done in the process planning. And after the process planning, next step is the process control. Process control means overall control of the project. That means we have to identify the progress of each task. That is, what is the current status of task 1, or what is the current status of task 2, like that. So if you want to identify the progress, or suppose that if anything is deviating from the actual situation, we have to make corrective action. So proper controlling is done in this step. And after this step, the last step is normally the final product evaluation or verification, validation, and testing. That is in the case of software, we are using these terms, and in the case of system engineering, we are using this term. So here actually your final product is created, and now you have to evaluate your final product, and proper documentation need to be done, and that is done in this last step. So this is the explanation of each and every steps, and the term which is used in system engineering and software engineering, and its description is given here. The next task is, what is the role of a software engineer? We know that software engineer is the person who is whose main aim is to solve a problem, that is to find the solution to a particular problem by creating a software. And it is actually a human activity which is biased by the previous experience. So since it is done by human errors will be there. So a good software engineer should recognize if any errors occurs, and he may try to eliminate these errors. So normally when anybody asks what is the task of a software engineer, we may think that the software engineer is just creating the code. But only less than 10% of the time is spent by the software engineers in order to write the code. The rest 90% of the time he is spending for other activities which are more important than writing a code. So these are the different activities that is usually done by a software engineer. And most of the software engineers will not be experienced in all the fields. They may be experienced in some of the fields. For example, some may be experienced in testing. That is, they may be working more for testing. So normally software engineer will be experienced in any of the subset of this different task. And the tasks are eliciting requirement, analyzing the requirement, writing software requirement and documents, building the analyzing prototype, developing software design, writing software design document, researching software engineering techniques or obtaining information about the application, developing the test strategies and test case, testing the software and recording the result, isolating problem and solving them, learning to use or installing or configuring new software and hardware, writing the documentation such as user manual, attending the meeting with colleagues, customers and supervisors, archiving software or readying it for distribution. So these are the main tasks which are very important than writing a code. And this may not be in order, but these are the main tasks which should be performed by this, which are the tasks of the software engineer. So, as I said, now the software engineering is trying to become an engineering stream, because as I said, different standards are there. So here we can hear some examples of standards in different fields are explained. This is some examples of standards and certification. So we know that different companies or different organizations are providing certification in software engineering, and these are some of the examples. Then these are the process standards. If you want to create a process, we know that a process creation, a software creation includes different stages. And for each process, certain standards are there, and these are some of the examples. So here the first one is a standard for IEEE standard for software quality assurance plans and software quality assurance planning. So different standards are there for each of the process. And these are some of the examples of product standards, the standards that should be met by the products, final products. And these are the standards for resources and techniques used in order to create the software. So like that, different standards are there for creating the software.